Lesson 1.1.3 continuing, recognizing functions and function families. In this video, we will determine if a relation is a function. So vocabulary, function notation. Function notation is a way to represent functions algebraically. Consider this scenario. U.S. Shirts charges $8 per shirt plus a one-time charge of $15 to set up a t-shirt design. The equation y equals 8x plus 15 can be written to model this situation. Name f of x equals 8x plus 15 is another way of writing out this equation. F of x is the name of the function, and then x is the independent variable. The cost defined by f is the function x, defined as the number of t-shirts. The cost defined by f is a function of x, defined as the number of t-shirts ordered. C of s equals 8s plus 15, where the cost defined as c is a function of s, the number of shirts ordered. So this is another way we could have written it. We could have used c and s instead of f and x. Okay, C, and use letters that represent what we are talking about. So the only thing you needed to write was the definition from this here. And then I was using a word problem to symbolize what we were doing. Determine which relations represent functions. If a relation is not a function, state why or why not. So we were doing this before with the graphs, and now we're going to do it with ordered pairs. Okay, and so when we look at the ordered pairs, remember that the vertical line test meant that if you drew a vertical line, a single x value only has one y value, and in this case it would have two. So we're looking at this list of ordered pairs with the same kind of eyes. So we're looking at all of the x values, and as long as the x value doesn't repeat in the list, it's going to be a function. Okay, so this is a function because none of the x values repeated. So go ahead and pause it, try number 2, and determine if it's a function or not. Okay, so now that you've tried it, so it's not a function, and it's because there are repeated x values in the ordered pairs. The -2 is repeated and -1 is repeated. So do make sure you finish the other 2 problems that are like this, and then move on to the next set of notes. Determine which relation, it's the same directions. This time we're using mappings. So if we look at the mappings, again, similar idea. Each of the inputs should only have one output. So this first one is not a function. Four goes to 5 and -5. So that's why it's not a function. So go ahead, pause it, try 6, and unpause it and check and see how you did. So if you got function for 6, you are correct. Each of the numbers in the inputs go to one of the numbers in the output. So do make sure you do the other 2 problems that are like these. Nine. So this time we're going to do the same thing, but this time with the table functions, or the tables. So again, you're looking at inputs going to one output. Well, the way you can tell if the input goes to more than one output is if the input repeats a number. And so if we look here, none of the numbers repeat, so this is a function. So go ahead and pause it and try number 10. So this one is not a function because 5 goes to 3 and to 5. It repeats in the input column. And with that, that is how you determine which relations represent functions from a graph, from a mapping, from ordered pairs, a mapping, and a table.